So this video is going to be all about mass movement in the coastal landscapes. But before we get into it, just from what we've done so far, in your head just name the 5 types of erosion that we looked at and describe each one of them. Okay, so pause the video, give yourself a couple of minutes. If there's any you can't do, obviously just go back and recap them, and then when you're ready, just move on. Mass movement, what is it? So in its really simplest terms, it's where big chunks of rock and cliff move downwards under gravity. There are a few different types that we're going to look at today, but essentially when you hear the term as mass movement, think right, mass is there's a lot of it and it moves, and it all moves downwards and it's all pulled down due to gravity. Okay, it usually happens in coastlines where you've got high relief, so that means it's really steep. It might be hilly, so it usually affects cliffs. And why does it happen? Well, it usually happens where for some reason something has changed to make the cliff unstable. It could be that it's been cut out at the bottom due to a Wavecut notch. It could be after a period of rainfall where the water's soaked into the cliff and it's added a lot of weight to it. Kind of like when you have a dry sponge, it's really light, and then when you soak that sponge in water, it gets really heavy. The same thing happens to cliffs. Okay, so it's usually to do with a bit of undercutting, but it can be to do with more water being added, but that depends on the rock type. So if you've got a rock that's really permeable, it's just going to soak up loads of water, act like a giant sponge, and eventually it will collapse under its own weight. If you've got a more resistant type of rock, it's often undercutting that causes it, and Wavecut notches, like we'll see in the following slides. In these 3 pictures, you can see some really clear examples of Wavecut notches. In the bottom picture, you can see a Wavecut platform underneath the Wavecut notch as well. Obviously, if you look at these 3 pictures, you're thinking, well, I know what's going to happen in the not too distant future. These notches are going to leave the material above it unsupported, and that is going to collapse into the sea. When that does, that will be classed as mass movement, because it will be a lot of material moving downwards under gravity, collapsing under its own weight. You wouldn't want to be stood around when one of these happens, because they can be quite violent, and there are a few deaths every year in the UK from cliffs collapsing onto people at the bottom of it. Nice. First type of mass movement is a rockfall. Now, rockfalls, as it says in the name, are where rocks that are attached to part of the cliff break away and fall downwards. This usually happens at vertical cliff faces, where the rock will have some time where it free falls away from the cliff, it catches some air, and it eventually ends up on the beach below it. So I've got 3 pictures there, 2 photographs and 1 diagram. You can see that the result of a rockfall is a lot of material at the base of a cliff and a new freshly exposed cliff face. Some of the causes of this is undercutting, like we talked about in the last slide, but also freeze-thaw weathering. So water will get into the cracks in the rock, freeze overnight, expand, force the gap to be bigger, and then part of the rock will fall away. And again, these are usually dry movements, so they'll happen without the sea acting at once. So this will just be a gradual thing, and they happen very fast. As you can imagine, the rock will collapse. It will end up in a big heap at the bottom. It will look quite violent. It will look quite drastic. I'll put some links in the bio on the video, so feel free to have a look at them. Okay, so that is a rockfall, where the rocks fall. The second type is a landslide. As the name suggests, there's no falling involved here, it's all just sliding downhill. The diagram here shows this quite well. This often happens on sedimentary rock where you've got layers built up on top of each other, and the slide usually happens along one of the fault lines. So you can see in the diagram you've got the area of black and white stripy rock and the area of brown rock sat on top of it, and there's a fault between the two. Those two rocks will be joined together, but what will happen is water will seep in. It will form a film along the barrier between the two rock layers, and that will then allow the rocks to move downhill. This usually happens with more fragmented soils like clay sat on top of it, and the slab will move downhill in one big chunk. So that area at the bottom of the arrow, that would have all broken off at the same time and moved downhill in one big slide. It can happen because the bottom of the cliff gets undercut, or humans have done something like removed it to put a road in or something like that. So the bottom of the cliff gets undercut, the top layers are then unsupported, and eventually they just slide downhill. Like I said, can be after a period of rainfall where water gets in, adds a bit of weight to it, or it could just be that the base has been removed. So landslide, the land breaks away and slides. Runoff can cause mass movement too. So for example, when you've had a massive snow melt in, for example, springtime, or you've had a lot of intense heavy rainfall, that water can come gushing down at once and just take away the top layer of material with it. So yeah, that will happen. Basically the top layer gets washed away and it just leaves behind a different type of rock below it, usually a harder, more stable rock. So that's runoff, to do with water. You should be familiar with that term anyway from water and carbon cycles. So lots of water flows over an area, it becomes released from one way or another, and it just takes away the top layer of sediment with it. Runoff. So the next one is a mud flow. Now this happens usually after periods of intense rainfall, where the water soaks into the hillside, adds its weight to the mud that's already there, and then that mud, as it's newly liquefied, it starts to flow downhill, and it will leave behind a hollow on the landscape, as you can see in the diagram on the right there, and it will sort of create a channel, and then at the bottom of that channel you'll have a delta or a fan where the mud flows out across it. Now this could happen on the coast, on a hillside along a coastline, and then obviously this will supply sediment to the coastal system. Now all of these, in fact, all of these types of mass movement are a source of sediment in the coastal landscape. So make sure that you're clear in your head that mass movement provides loads of sediment to the coast, and that can reshape the whole coast along it. Slumping. Now this usually happens in cliffs made out of substances like clay, and also cliffs where you've got pre-existing faults in it. So what happens is essentially the base gets undercut by wave, and the weight of the rock on top of it causes that mass block to slide downhill, but in a curved motion. So you can see in the two diagrams that it kind of curves round at the bottom, and you get this curve shaped collapse. And the way it collapses, it actually leaves behind these kind of like steps that are called heads, steps downwards. So you can see in the picture in the bottom left and in the bottom right that you've got these steps in the landscape, and that is a classic telltale sign of slumping. So yeah, what happens is the base of the cliff gets cut out by the sea, the rock above it slides down in a rotational motion, and causes these distinctive heads or steps that you can see there. It might be that rain's got in and lubricated the pre-existing faults there, which has helped it, But yeah, slumping, make sure you're familiar with this. And again, if you see these steps in the landscape, just think, slumping, beautiful. So the final type of mass movement you guys need to know about is called soil creep. Now this happens, this is probably the most gradual of all the processes, the least dramatic. And what happens is individual particles move downhill under the force of gravity, and obviously this is going to happen on a much smaller scale. You can see in the two pictures that you get these ripples on the hillside, and this is a classic sign of soil creep, and you often get these breakout areas as well. So you can see in the picture on the bottom left, you've got kind of a bit of a break where the soil below it is sort of going a bit quicker than the soil on top of it. So if you see a hillside like this, you can see, well, actually it's the particles moving downhill under gravity that's caused this. This can happen on sand dunes as well, and on coastal fields and things like that. So this isn't going to provide much sediment, but it will provide some sediment to the coastal zone. So that's soil creep, where the soil particles creep along on quite a small scale. So using your knowledge of mass movement that you've just gained, what I want you to do is look at the map of Torbay on the right hand side, all the different rock types in there. And I want you to think which type of mass movement is most likely to affect Torbay and Torquay. So just come up with some answers, come up with some explanations, maybe 1 or 2 points, just develop them. You can email those across to me or just attach them to the post on Google Classroom. And then have a think and make some notes about what you think can be done to prevent or to reduce mass movement along the coast. Now I'll put these 2 web links that you can see there in the bio of the YouTube video as well, so feel free to have a look at those. But yeah, use your local knowledge here. You're all from Torbay, you've all lived here for a prolonged period of time. So yeah, which types of mass movement will affect Torbay? Try and think where will affect them as well. And yeah, just get those answers across to me when you're done. And finally, to end with, I've dug out 2 exam questions about coasts. So you can see you've got a 4 marker and a 6 marker there. The 4 marker, that's the smallest answer question you'll get. So it's usually to do with a definition or a key idea. So this one, explain the concept of a sediment cell for 4 marks. So that's no more than maybe 5 or 6 lines maximum for that one. And then the next one, using figure 7 and your own knowledge, assess the role of mass movement upon the development of this area of the Holderness coastal landscape. Now, just to make it clear, when it says the development of this area, it does not mean human development. It means the development of this area in terms of its physical landscape. So that is an important one to take into account as well. Okay, so we're not talking the human development, we're talking the physical development. Okay, so again, have a go at those. Should be about a page for those 2 between them, and then just email those across to me. Excellent.